All right, Calc kids, you made it. This is the final semester 2 review. It is 43 questions, I think. So we're going to do we're going to separate this into 3 days. We're going to do the first, I think, 14 questions because that's the end of chapter 5. So we'll cut it off here at this video. Hopefully this isn't too long. But what I'm going to do is I'm going to go through here and I'll probably have you answer some of the questions by yourself. Or I'll at least get you started and we'll go through this entire review somewhat together. So starting with number 1, this is all taking the derivative in chapter 4. So this is the product rule, quotient rule, chain rule, power rule, all of that good stuff, okay? So number 1, I think they're trying to trick you in number 1 because since there's just 3 in the bottom here, you can just write this as y equals 2/3 x squared plus 5/3 x. Okay, you can divide both of those by 3, and then it's really easy to just do the power rule. Okay, so if I drop the 2 down in front, 2/3 times 2 is going to be 4/3, but now it's x to the first power, and then plus 5/3, and then x will just drop off. Okay, so that's what y prime is going to be, and there is his first derivative. Okay. All right, the second one, find an equation for the tangent line of the graph of that thing at the point x equals 1. Okay, so I'm going to, the equation of a tangent line is y equals mx plus b. But when we take the derivative of something, that's going to give us the slope of our tangent line. So if this is what our tangent line equation is going to look like, this guy will be the derivative of the equation that they give me. That's the slope of the tangent line. Okay, so I need to, and it tells me at the point where x equals 1. Okay, well, if x equals 1, let's go ahead and figure out what the y coordinate is by plugging it into the original, because we really need 2 points. Eventually we will. So if I plug 1 in here, 2 times 1 squared minus 2 times 1 plus 3 should just give us, I think, 3. 2 minus 2 plus 3 is just 3. So 1 comma 3 is the point that we're plugging in. All right. Now, let's find the derivative of this guy. So f prime of x is going to be 4x minus 2. The 3 just drops off, okay? So this is going to give me the slope of my tangent line, and I'm going to plug 1 in for x there. So if I plug 1 in here, 4 times 1 minus 2 is just going to give me a slope of 2. So I'll have y equals 2x plus b. All right, and then the last thing I do is to solve for b. I'm going to plug 1 and 3 in for x and y. So this is where I'm going to use that 3 value. Okay, so 2 times 1 plus b. This is just going to give me 2. So b is going to be equal to 1. And then writing my final equation, y equals 2x plus 1. That's what he is going to look like. So this guy is the tangent line to this point, or to this equation at the point x equals 1. Or really, it's the point 1 comma 3 if I plug in and solve for y. So that's what he's going to look like. Okay. All right. Number 3. What rule are we going to have to use when we're trying to find the derivative of this thing? Okay. That is a fraction, or it's a quotient. So we're going to have to use the quotient rule. Okay. Quotient rule says f prime g minus g prime f all over g squared. Okay. All right. And we're not going to simplify too terrible much. I don't want to completely kill our brains trying to find the derivative. So f prime, f is going to be the top, g is going to be the bottom. Okay, this is kind of taking us back a little ways. Finding the derivative of f, or finding the derivative of the top, that's just going to be 3. And then we just rewrite our g, so x squared plus 1, minus g prime, so the derivative of the bottom, will be 2x times the top, which is 3x, and then all over g squared. And I'm just going to leave him as x squared plus 1 squared. Okay, so that's what he will look like. All right, if we simplify the top just a little bit, I'm going to distribute the 3 through. So I will have 3x squared plus 3 minus 2x times 3x is 6x squared. Okay, and then if I just do one more thing where I combine like terms on the top, 3x squared minus 6x squared is going to be negative 3x squared plus 3 all over. I'm going to leave the bottom. X squared plus 1 squared, there he is. Okay. All right, number 4, this is a product, and you could multiply those together if you wanted to, FOIL it out, and then you just use the power rule. But let's go ahead and use the product rule on this one. I'm going to have you do this one on your own, and then I'll just show you the answer. Okay, so plus 2.f. Okay, so here's my work, and this is what I got for number 4, negative 30x plus 7. Okay, moving on to number 5, so we have this guy right here, and they want us to find the derivative again. So this guy I'm going to rewrite as the square root is to the 1/2 power. So this is going to involve the chain rule. So I bring the 1/2 down in front. 1 minus t will stay, and this is now going to become the negative 1/2 power when I subtract 1. But then I have to also multiply by the derivative of the inside. So the derivative of 1 minus t is just going to be negative 1. Because if I take the derivative of negative t, that's negative 1. Okay. Then, since I have negative exponents, I'm going to put like a fraction a bar, stuff that goes in the top. 1 and negative 1, or just negative 1 goes in the top. And then I would have 2, and I'm going to switch that back to a square root. 1 minus t goes in the bottom. That's what he will look like as a derivative. Okay? All right, I'm kind of going through these somewhat fast because I don't want to take forever on this video. But if I'm going too fast, make sure you pause or backtrack or do whatever you need to. This one, they want us to find the second derivative. Okay, so I'm going to start with this guy, but I'm going to write him as 12x to the 1/4 power. 12x to the 1/4 power. Okay, the fourth root is 1/4 power. Now I do just the regular power rule again. If I bring the 1/4 down in front, 12 times 1/4 is 3. X to the, if I take 1/4 and subtract 1, that will give me negative 3/4. Okay, so this is my first derivative. Now if I do it again, because I want the second derivative, if I multiply that down in front, so that's going to be negative 9/4, because this is like negative 3/4 times 3/1, so negative 9/4. X to the, if we subtract another one of these, that's like subtracting another 4/4. That's going to give me negative 7/4. Okay. Now if I put them back together, negative 9 is on the top and 4 is on the bottom. Okay. But negative 7/4, this is going to be the fourth root of x to the 7th power. Okay. So that is kind of, there's probably one of each of those, the chain rule, power rule, quotient rule, product rule in chapter 4. Okay. Moving on to chapter 5, which is applications of derivatives. So that's like finding the maxes and mins, finding the points of inflection using these wonderful tables here. Also Rolle's theorem and mean value theorem. So Rolle's theorem basically says that if I have a curve or some point where the y coordinates are both at 0, then he's going to have a point where the derivative, where f prime is equal to 0, where he has a horizontal tangent line. Okay. And we're going to try to find where that point is located at. So apply Rolle's theorem to this guy by finding the values of c in the interval such that f prime of c equals 0. Okay, so let's go ahead. I want to multiply this thing out. Okay, so x plus 3 squared, if I distribute him or FOIL him out, he will be x squared plus 6x plus 9. If we go ahead and multiply him out, okay? And then I'm going to multiply him by the x minus 2, so that is, oh boy, x cubed plus 6x squared plus 9x minus 2x squared minus 12x minus 18. That's what he is, okay? And then if I rewrite him, I'm going to put him down here. If I combine like terms, x cubed plus 6 and negative 2 is 4x squared. 9 and negative 12 is negative 3x minus 18. There he is. Okay, and now I want to take his derivative and set that equal to 0. So I'm going to start with this guy. I'm going to say this is 3x squared plus 8x minus 3 equals 0. Yuck, yuck, yuck. Okay. This is a complex trinomial, so I have to take 3 times negative 3, which is negative 9, and that will give me 9 and negative 1 to multiply to get 8. Okay, so I'm going to write them as 4 pieces now, so 3x squared plus 9x minus 1x minus 3 equals 0, and then I group. Okay, we're getting close to the end here. I want to pull a 3x out. So I'm left with x plus 3, and in the second part I'm going to pull a negative 1 out, and I'm left with x plus 3. Okay, and I set both of those, well, my 2 pieces now are going to be 3x minus 1, and x plus 3, and he's equal to 0. Okay, so this first piece, if I set him equal to 0, I'll get x equals 1/3. Second piece, I'll get x equals negative 3. Okay, so those are my 2 places, or my 2 values of x, where he's going to have a horizontal tangent line or where his derivative is going to be 0, but I'm only looking at, or I'm only concerned with values that are between negative 3 and 2. So, and it's inclusive, so it's including negative 3 and including 2. Okay, so both of those are actually going to fit in that interval, so I'm going to circle both of them. Okay. Now, Rolle's theorem as opposed to the mean value theorem, in this case, I'm not setting the derivative equal to 0. I'm setting f prime of c equal to the slope, between these 2 points, 1 and 8. Okay, so I need to do 1 comma something and 8 comma something and figure out what the y coordinates are. Okay, so 1 to the 2/3 power is going to be 1. 8 to the 2/3 power, this is kind of like saying the cubic root of 8, and then that guy squared. Okay, cubic root of 8 is 2, 2 squared is 4, so I'm looking at that guy right there. Okay, now if I do the slope, I do y2 minus y1 over x2 minus x1, 8 minus 1. Okay, and that's going to be 3/7. Okay, now, last thing, so now that I found my slope, I need to take the derivative of my original and set him equal to 3/7. Okay, so my derivative of this guy is going to be 2/3 x to the negative 1/3, and I'm going to set that equal to 3/7. Okay, then, oh my goodness, what a mess I have. Let's do this. I'm going to multiply by 3/2 here. Okay, and so, and really then this is 1 over the cubic root of x, is what x to the negative 1/3 is, equals 9/14. Oh my goodness, that's so ugly. That is super, super, super ugly. Okay, when I have this fraction here, this will be the cubic root of x equals 14/9. If I want to flip that, so I just flipped and flipped, and then to get rid of the cubic root, I'm going to cube both sides. So x is going to be equal to 14/9 cubed. Oh my goodness. Yeah. 14 divided by 9. And I'm going to take that to the 3rd power. That is 3.76 approximately. That's where his derivative is going to have a slope of 3/7. Gross. That's grossness. Yucky. Yucky, yucky. Okay. I'm not a particular fan of the mean value theorem, but it has its important parts, I guess. Okay. All right. Number 9. Find the critical numbers of this thing. So we're trying to figure out intervals upon which he's increasing, decreasing. So that's just going to involve first derivative of this guy. So I have first derivative is 3. If I take the chain rule, 3 times x plus 1 squared, 1 squared. Okay, and then I have to take the derivative of the inside, which is just 1. Right, the derivative of x plus 1 will just be 1. Okay, now I have to set that equal to 0, so let's just do this. 3 parentheses x plus 1 squared equals 0, because that 1 multiplied by 3 is just 3. Then to solve for x, I'm going to divide by 3 here. So I have x plus 1 squared equals 0. Okay. If I take the square root of 0 is just 0, so I have x plus 1 equals 0, and x is going to be equal to negative 1. That's what he will look like. Okay. So now I have two critical numbers. Okay, or I have one critical number. I have two intervals. So the intervals go from negative infinity to negative 1, and from negative 1 to infinity. So let's pick some test points. I'm going to test the point, I didn't put a column or a row in there for this. I'm going to test negative 2, and I'm going to test 0. Okay, those are going to be my numbers that I'm going to test. And I'm going to plug them in to my second derivative, or my first derivative, excuse me, which is 3x plus 1 squared. So if I plug negative 2 in there, okay, 3 times negative 2 plus 1 squared. Is that right? Okay, keep going. It's going to be negative 1. Negative 1 squared is 1, so 3 times 1. This is going to be a positive number. Okay, and now if I plug 0 in, same thing. 3 times 0 plus 1 squared is still going to be 0, or is still going to be a positive number, because 1 squared is 1 times 3 is going to be a positive number. So this one is increasing here, and it's increasing here. Okay. Now normally we have increasing and then decreasing or something like that, and we can determine whether it's a max or a min, but it's increasing basically on the entire graph, which makes sense because it's x cubed as a function, and x cubed does this. He's never decreasing. So he is increasing on the entire interval. Determine the intervals upon which he is increasing, decreasing. So I could lump those two together and say increasing on all reals, or I could say from negative infinity to positive infinity. And that's what he's going to look like. Okay? All right, let's keep moving on. This one is going to be a find the relative extrema. Okay, so same type of thing, except now we're doing the maxes and mins as well. Okay, so let's take this guy and take his first derivative. If I multiply the 4 down in front, he will be just 1t to the third power minus 8. And if I set him equal to 0, okay, I can add the 8 to the other side, so t cubed is going to be equal to 8, and take the cubic root. And the cubic root of 8 is just 2. It's not plus and minus 2 because it's cubic root. So it's just 2. Okay, so my two intervals go from negative infinity to 2, and from 2 to infinity. Okay, and let's do 0 in this case, and let's do 3 in this case. Okay, so if I plug 0 in, 0 cubed minus 8 is going to be a negative 8, or just a negative number. 3 cubed is going to be 27 minus 8. That's a positive number, like 19 or something like that. Okay, so this means he's going up here and he's going down here. So the point 2, comma, whatever that 2 is going to be a maximum. So I'm just going to say he has a max at 2, because he's increasing and then he's decreasing. So we're going to say he's a max at 2. We could find the y-coordinate if I want to plug it into there, but we'll just move on to the next one. Okay, I don't want this to be a terribly long video, and I think it's already going to be. Number 11, determine the points of inflection. So here we do second derivative. Okay, so let's do second derivative of this guy first. Let's do, okay, so we'll start negative 3x squared plus 12x minus 9. That's my first derivative. Okay, second derivative is going to be negative 6x plus 12. Hey, that's kind of nice. Now I'm going to set the second derivative equal to 0. That's this guy. Okay, so Kaylin's going to hate this, but I'm going to move the 6 to the other side. Ha! 12 equals 6x, because the 6 is negative, and I don't like negatives. And then x will be 2. Okay, so I have two test intervals, negative infinity to 2, and 2 to infinity. Okay, And then let's pick the point 0 here, and let's pick the point 3 here, just like we did in the last problem. Okay, but now we're plugging into the second derivative. So if I plug 0 in here, negative 6 times 0 plus 12, that's going to be a positive 12. I'm just going to have a positive number. If I plug 3 in there, okay, negative 6 times 3 is negative 18 plus 12. That's still going to be a negative number. Okay, so what's happening here is this is concave up, and this is concave down. Okay, which means that there is a POI at 2 comma something. And we would plug it into the original equation to figure out what the something is. Okay, but I'm just going to say POI at x equals 2. Let's just say that. Okay, and then we won't have to plug it back in. Okay, all right, last couple ones. Hopefully they go fast. Find the limit. What we notice is if we try to plug infinities into here, we would end up with infinity over infinity. Like 2 times infinity squared is still going to be a really big number. 3 times infinity squared is still going to be a really big number. But infinities, or limits at infinity, a limit at infinity is directly related to the horizontal asymptote. Okay, and the horizontal asymptote, the rules for those were if n was, let's say n is less than m, your ha is y equals 0, or your limit would be 0. If n is equal to m, you would look at the leading coefficients. And if n is greater than m, then there would be none, or there would not be a limit. The limit would not exist. Okay? So in this case, my n and my m are both 2. So I'm going to look at the leading coefficients. So the limit as x goes to infinity is going to be 2/3. That's it. Very easy on that one. Okay. Now, vertical and horizontal asymptotes. So let's go ahead and do the horizontal asymptote since I've written the rules already out here. N up here is 1. M down here is also 1. So I look at the leading coefficients out in front. So the ha is going to be y equals 2. That's what he looks like. Okay. And then to find your vertical asymptote, you set the denominator equal to 0, because I don't want that bottom to ever be 0, and that's where my vertical asymptote is going to live. So if I set x minus 4 equal to 0, x is going to be 4, and that's going to be my ha, or my va. So va is x equals 4, your ha is going to be y equals 2. And that's what he's going to look like. So he'll probably, let's see, x equals 4, y equals 2. He'll probably be, like a boomerang equation that looks like this, where my vertical and horizontal asymptotes are those guys. Okay, last one. Determine the dimensions of a rectangular solid with a square base. Maximum volume, so volume of a rectangular solid. Okay, volume of a rectangle is, with a square base. Okay, let's do that first. Here's my rectangular solid. There's what he looks like. Okay, and since he has a square base, so I'm going to call this dimension right here x. But since he's a square base, then both of those dimensions are going to be x's. And then I'm going to call this guy y. So if I'm trying to find the volume of him, okay, it would be x times y, or x squared times y is what he would look like. Okay. And then if I'm trying to find his surface area, oh my goodness, that's a lot of surfaces. Let's see. Well, all of these side surfaces, like all the way around the sides, are going to be x by y, x by y, x by y. So I will have 4 just xy. This will be part of my surface area. I will have 4 sides that are xy's, and then the top and the bottom are just x by x's, or x squareds, and there's 2 of them. Okay. So this is going to be my surface area equation, and my surface area I know is 337.5. Okay, so yucky. Okay, what I want to do with this is I'm going to solve the bottom equation for one of the variables, and the easiest one to solve for is going to be y at this point. Okay, and then I'm going to plug him into the top one. All right, so let's start moving things around. Let's kick the 2x squared to the other side. So I have 337.5 minus 2x squared equals 4xy. Let's do that. Okay, and then if I'm trying to get y by itself, I'm going to divide by 4x. Okay, and so y is going to be this guy right here. Okay, all right, now let's see what I can do with this. This is what y is. Y is equal to that junk. Okay, now I'm going to plug him into the top one here. So I'll have x squared times that whole big thing. 337.5 minus 2x squared over 4x. Okay, now one thing that I notice is that this x can cancel with one of those. And then I can just distribute my x through. Okay, and then I'm also going to divide by 4. So 337.5, this will be 337.5x divided by 4, or, let's see, 337.5 divided by 4 is 84.375, and he'll have an x on him. So I'm going to go ahead and take that dividing by 4 and strap an x onto him, minus, this will be 2x cubed divided by 4, or 1/2 x cubed is what he will look like. Okay. All right. Last thing that I have to do is I have to set him equal to 0. Okay. Or no, shoot. I have to find his derivative. I haven't found the derivative yet. Huh. Okay. So after I solve that all out, I have to find the derivative of this guy. So 84.375. There's no x, minus 3 times 1/2 is 3/2 x squared. Okay. Now I'm going to set him equal to 0. Okay, so I'm going to lump this 3x squared to the other side. 84.375 equals 3/2 x squared. Okay, and then I solve. So multiply by 2/3 times 2/3. Okay, so I have that 84.375. I'm going to multiply by 2 and divide by 3. So I have x squared equals 56.25, and I can take the square root. 7.5. So I want my x to be 7.5, and then my y, oh boy, ugh, yuck. X is 7.5. Let's see, determine the dimensions of a rectangular solid. X has to be 7.5. If I plug that into here, that will tell me what y has to be. So y has to be, parentheses, 337.5 minus 2 times 7.5 squared divided by 4 times 7.5. And the y will also be 7.5. Well, that's kind of exciting. So there is that, okay? All right, whew, that was a lot, okay? We'll do the next little bit tomorrow in the next video, and hopefully that will be a little bit shorter because we won't have all these boxes to deal with. So this should be the longest one, I hope.